Okay, Bella, today we're going to practice solving word problems by writing systems of equations. So let's take a look at this first example here. It's nice and simple. It's actually a problem that you could probably solve just using guess and check because it's that simple. But it's a great place to start because it shows you how to model a word problem using a system of equations. In other words, we're solving a word problem where there are not one but two unknowns, an x and a y. But there's enough information for us to write two equations. So for this first one, it says the sum of two numbers is 25 and their difference is 7. Find the numbers. Now, anytime you're writing any equation, it's always a really good idea to define your variables. So I've done that for us here. Let x equal the larger number and y equal the smaller number. And now if we break this down, there are essentially two equations we can write using these variables. The first one is right here. It says the sum of two numbers is 25. So we'll just stop right there. And that's a really simple equation, right? X is one of the numbers, y is the other. So x plus y equals 25. And then here is the second equation. Their difference is 7. Okay, well again, same two numbers, right? But now, if I subtract them, if I take the larger number x and subtract y, that gives us 7. So what we've just done is we've written a system of equations to represent this problem. And now we can solve this system of equations using the methods that we've practiced the last 2 days. Now, we've learned a couple. One of them is that elimination method, and then the other one is the substitution method. Ask yourself, which one do you think we should use here if you take a close look at the variables? Well, I would certainly go with the elimination method, because if I add these two equations together, the y's are going to cancel out. Positive y will cancel out with negative y. So that's going to give us 2x equals 32. And then we divide both sides by 2, and we get x is equal to 16. Okay, from there, now we just ask ourselves, okay, well, what's the sum? X is one of the numbers, 16, and 16 and the other number has to be equal to 25, so this one you can probably just solve in your head. You're just plugging it into this equation here. So that's going to give us 16 and 9. Not 9. Yeah, 9. Excuse me. All right, so 16 and 9 are the two numbers. Sum of 25, difference of 7. All right, now for this next one, it's a little bit trickier. It says a library contains 2,000 books. There are 3 times as many nonfiction books as fiction books. Write and solve a system of equations to determine the number of nonfiction and fiction books. Now, if you look right here at the end, they tell us the two variables that we're solving for, the two unknowns. One of them is the number of nonfiction books, so we can call that x. The other is fiction books, and we'll call that y. For sake of argument, it doesn't matter which letter you ascribe to which variable. It could be xy, yx, or ab, whatever you like. Now, if you look here at the very first sentence, it tells us what one of the equations is. Because remember, this problem requires a system of equations, so we have to write two. A library contains 2,000 books. Well, x is all the nonfiction, y is all the fiction, so the sum must be 2,000. X plus y equals 2,000 books. Now, this next one is a little trickier to write. It says there are 3 times as many nonfiction books as fiction books. So now I'll give you a hint here. This is an equation where on one side you're going to have x and on the other side you're going to have y, because this equation compares one to the other. It's not saying anything about how many books there are. It's not saying they add up to 2,000. It's just saying, okay, what is the ratio of nonfiction to fiction books? Well, 3 times as many nonfiction books means that you would take the number of fiction books and multiply it by 3, right? That's how you'd figure out how many nonfiction books there are. So the number of nonfiction books, x, is equal to 3 times that of y. So in other words, just for sake of it, you can test it with a number to see if let's say there were 200 fiction books, right? Well, if there were 200 fiction books, that would multiply by 3 and give me 600 nonfiction books. So that holds true, right? 3 times as many nonfiction as fiction. Okay, now ask yourself, here's our system of equations. How can we solve this? Which method should we use? Well, this is really kind of begging you to use the substitution method because we have a variable solved for right here. We have x defined in terms of y. So what I'll then do is I will write this equation, 3y, substituting this for x, just plug this in, 3y plus y equals 2,000. And this will solve pretty simply. I'll do 4y, combine my like terms, 4y equals 2,000. And then y equals 500. So there are 500 fiction books, because remember we have y refers to fiction books, 500 fiction books in the library. And now just take this number 500, plug this in for y either in this equation or this equation. Looks like we're going to get, well, x plus y is 2,000, y is 500, so x is 1,500. So we'd say that there are 1,500 non-fiction books and 500 fiction books. However, if that is an ordered pair, it would be 1,500 and 500. Okay, so we'll do more practice on this today. Like I said, the real trick to all of this is setting up the equations. Once you have this part done, the rest is pretty straightforward.